So here's another tool that can help you to significantly optimize the performance of your application, especially if you're working in a distributed system. Kafka. Most of the applications that we use today are designed and architected to be microservices, which means that instead of having your entire application packaged in one single application, we have various applications, various mini smaller services that are connected together in some way that form the entire application. So you can have one application that is your transaction application, another application that is your product application, another application that is your checkout application, another application that's your various services doing specific functions. And that helps to create a more efficient system so that a problem happening in one part of one application doesn't affect the entire application and you can scale independently. However, the problem there is that these separate applications need a way to send data and communicate with each other, and sometimes that can become a problem if a lot of transactions, a lot of data are being pumped from one application and are supposed to be received by another application and processed. So while this service is trying to process the data that's coming into it, more services are coming in and it's still trying to process, and sometimes it could lose some of the data coming from these services, and that could in some cases be a lot of money lost. What we do is that we have an event streaming tool that helps to stream this data effectively. So instead of sending data directly to the receiving application, instead of sending your data from one service directly to another service, if you see that there is the tendency for this service to have sending a lot of data and the other service will be receiving all of that data while still having to process it, so you can broker it a bit using an event streaming tool that helps you to collect that data and send it to the other service. That's what Kafka does. How it works is that the Kafka cluster, which consists of probably many nodes running Kafka, serves as the broker between these two services. One, the service that is sending the data is known as the producer, and the service receiving the data is known as the consumer. So the producer sends data to Kafka, and the Kafka brokers, which are the Kafka servers, receive that data into topics. The data, we can refer to them as messages. So it receives the messages and stores them in various topics and partitions them across its various nodes. It's partitioning them in order to save them efficiently, and it tags all of them within those topics. So your data coming into Kafka can be separated among various nodes and then recoupled by Kafka and sent to the consumer when that consumer is ready and to process it. Kafka also persists that data, so it saves the data for as long as possible, depending on the retention policy that you set on Kafka. So if you do lose data ever, you can always replay it from the Kafka service. So the real world cases where you'll be using Kafka as a DevOps engineer would be probably in log ingestions. So if you have various applications and you need to collect logs from various applications, various environments, maybe your low-key logs or your Elasticsearch logs, and you need to send them maybe to Elasticsearch, you would use Kafka there in order to manage that, so that the logs are not just constantly being injected into your Elasticsearch, and you see that with time, while Elasticsearch is trying to do its processing, you might lose some log data. So you use Kafka as a broker between that to help your event streaming perform efficiently. You can also use it a lot in data applications. We have a lot of big data applications these days. So things like ETL processes, where you need to extract your data, transform the data, and load it into maybe a data lake for something like Databricks. You could have Kafka there to do your real-time event streaming for you efficiently, so that you don't lose any important data and you're able to manage that efficiently. Kafka is a very important tool in many microservice real-time applications. So you'll see it used heavily in fintech applications, you'll see it used heavily in social media applications, because those are data intensive applications and you don't want to lose any data. Lost data could translate into millions if you take it to the finance team. And We don't want that. If you're a DevOps engineer that's likes to take advantage of managed services, a lot of cloud providers have managed services for Kafka. The one I'm really sure of is AWS MSK that helps you to set up a Kafka cluster that's managed by the AWS team. I can just use it into your application. You also have HD Insights on Azure, which also helps you to have an event streaming real-time platform like Kafka as well set up for you. You can also deploy Kafka into your environment using the Kafka Helm charts in your Kubernetes cluster and set that up. You can also take advantage of Bitnami, who have also written the Kafka Helm charts. No one should ask me why I love Bitnami. Also, if you want a Kubernetes operator that can handle the entire lifecycle of your Kafka cluster, you have Strimzi that provides that for you. So you can get that set up in your Kubernetes cluster, your Kubernetes home lab cluster, which you should probably have set up by now, being the serious DevOps engineer that you are. You can have that easily set up in EKS. Get familiar with it, try your hands out with it, and in the future, your developers will thank you for it. I hope that helps. All right, I'll see you in the next one.